Hello, everyone. Hope you're having a good day. This is going to be episode 0 of a series that I'm starting called The Basics of Programming. I'm going to be discussing some basic concepts about programming in this episode and giving a general outline of what you can expect to see in the series. But if you don't care and just want to dive into the actual contents of this series, feel free to skip to episode 1 or to any other episode that interests you. So, firstly, let's ask, what is programming? Well, the answer to that question is actually very simple. Programming is just the process of giving instructions to a computer in the form of text. You are, at a very basic level, giving a computer a text file with instructions on what it should do, and if the text file is formatted correctly, the computer will execute those instructions. That is, in a very simplified way, what programming is. There is, of course, a lot of nuance to that, and in practice, it's a bit more complex than that. The text that we give to the computer is something known as machine code and has to follow a very strict format. Now, nobody really programs machine code because it's very unreadable and very difficult to learn on its own, so we've created what are known as programming languages. Programming languages are basically an easier and friendlier way to write machine code. Programming languages, much like spoken languages, all have their own syntax and structure. The difference between the syntax and structure of programming languages and machine code is that programming languages are designed to be easily written and understood by humans, and machine code is designed to be understood by your computer's CPU or processor. Of course, your CPU doesn't actually understand anything other than machine code, so code written in human understandable programming languages have to be translated into machine code. This generally happens in one of two ways: compilation and interpretation. Compilation is when your code is translated into something like a native executable, like an exe file on Windows, which can just be ran directly. Interpretation is when your code is not translated in something like a native executable. Instead, an interpreter comes in, reads your code line by line, and translates that code into machine code line by line. The main difference here is that when translation happens, there's a lot more to cover about the differences between compiled and interpreted languages, but that's a simple high-level overview to get you started, and we'll dive further into that in a future episode. So, now you have a basic overview of what programming is, but there's still another question. Which programming language do I learn? This is a question that everybody asks when they start out, and the answer to it is, it depends. You see, there's a reason why there's so many programming languages, and that's because there's many different fields of programming. For one, there's web development, where you'll be designing websites and infrastructure for them. Generally, web development requires the use of multiple languages such as JavaScript, HTML, CSS, and many others. These languages usually serve specific purposes in the process of web development. For example, HTML is responsible for creating the skeleton and general structure of the website. CSS is responsible for stylizing and decorating that empty skeleton, and JavaScript is responsible for adding actual functionality to the website so that users can interact with it. This is just a basic overview though, as there's a lot more to websites than just that, and the web development world moves pretty quickly. There's also data science, where you'll be processing large amounts of data, statistics, and analytics. This could be anything from scientific data to banking transfers to user analytics, and you'll commonly see languages such as Python, R, MATLAB, Julia, SQL, pretty much anything that can process large amounts of data efficiently. There's also game development, where you'll be, unsurprisingly, designing games. One of the most common languages you'll see in this field is C++, but game development happens in other languages as well. Minecraft, for example, is written in Java. You also have to consider game engines and what languages they support. For example, C# is used in Unity, and C++ is used in Unreal Engine. Some game engines also create their own language for game development. GameMaker Studio uses GameMaker language, and Godot uses GDScript. There's also embedded systems programming, where you'll be working at the device level. Think things like microwaves, thermostats, digital watches, electronic systems in vehicles, alarm clocks, and much, much more than just that. Lots of times this kind of development is done in constrained environments where performance and efficiency is paramount, so you'll see lower level languages such as C, C++, assembly, Rust, which all provide a lot of control for the developer. There's also general purpose programming languages which are used for a wide range of things such as C++, C, Java, Python, and many, many more. So as you can see, there's a lot of programming languages out there because there are a lot of fields and subdomains of programming. So again, to answer the question of what language you should choose, it depends heavily upon what you plan to do. For this series, I'll primarily be using C and C++, as they're both great general-purpose programming languages in which I can teach the basic concepts of programming in. However, I will also be using a wide range of programming languages in this series, as it is a programming series, not just a C, C++ series. So if I need to explain something in Python or JavaScript, I will. Okay, so now let's go over what you'll need to start programming, both efficiently and comfortably. Spoiler alert, it's not very much. Firstly, you'll need a computer with a functional operating system on it, which I'm sure you already have. Which operating system you choose is totally up to you and should have a mostly minimal impact on your experience for now. I'll be using Linux, but I'll avoid doing anything Linux specific so that the series will be accessible to anybody on any platform. Secondly, you'll need a text editor. A text editor is software that you will be using to write code in. An example of a text editor that you've probably already used before is Notepad. In theory, you could be the ultimate minimalist and just use Notepad for everything, but in practice, you'll want a programming text editor as they provide a bunch of useful tooling for programming. There's an abundant amount of text editors out there for you to choose from, but for now, I'll recommend that you install Microsoft Visual Studio Code. It's a simple text editor that's hugely popular and will work for basically any language that you choose to program in. Just make sure that you install Visual Studio Code and not Visual Studio, as they are two different pieces of software. Visual Studio Code is the blue one, and Visual Studio is the purple one. I'll personally be using Emacs, but again, it doesn't really matter what you use. You can experiment with text editors whenever you want. So, I just wanted to show you the difference between Visual Studio and Visual Studio Code, as this is a pretty common mistake a lot of beginners make when they're installing VS Code. This right here is the website for Visual Studio Code. It's a general purpose text editor that can be used with pretty much any language. It's very lightweight and it can be used on pretty much any platform. As you can see right here, they have the Linux installations in case I wanted to install it for Linux. Let's see what else they have. Mac OS, Windows, of course, it's developed by Microsoft. This, on the other hand, is the Visual Studio website. Visual Studio is an IDE, an integrated development environment. It's much, much heavier, the Visual Studio Code, and is mostly used for C or C++ or C# development on Windows. This isn't really what you want at the moment, so I would recommend that you install Visual Studio Code. Thirdly, you'll need to have whatever programming language or programming languages you intend on using installed on your computer. This is, of course, different for each language. For example, if you want to use C, you'll have to have a C compiler installed on your computer. If you want to use Python, you'll have to have the Python interpreter installed on your computer. If you want to use Java, you'll have to have the Java Development Kit or the JDK installed on your computer, and the list goes on. Again, I won't be showing you how to install any of these languages, as this isn't really a follow-along series, but there are multitudes of resources out there on how to install any language on almost any system. So now, let's outline what you could expect to see from this series. I'm planning on discussing and teaching the basic and up to intermediate concepts of programming, which can be carried over into any other programming language. I won't be using a specific language for everything, but I will mostly be doing this in C or C++, maybe Python too for simplicity, but I intend on bringing in other languages when I think it's necessary to show you a specific concept in multiple languages, which I'm sure I often will. Each episode will be centered around one specific topic so that I can give you, hopefully, a full understanding of these concepts. These episodes will also follow a general order. I'm not going to teach you about lambdas or sockets in the first episode. So, That's about all I wanted to address in this introductory episode. The first episode in this series will be about data types, and that should be released sometime soon after this. Thank you for watching. Have a good rest of your day.